Forming. Forming is metal forming. It is one of the highest weightage in gate manufacturing subject. The books you need to refer is, in metal forming you may get 3 to 5 marks in gate. So 2 marks question, 1 mark question, and 2 marks question, and 1 mark question. It varies from year to year. And books you need to refer is Sheet Metal Operations by Nagpal and Sheet Metal Operations by P.C. Sharma. You can look at the books. Metal Cutting by Nagpal. There are other textbooks which you can do. So forming. What is forming? Forming is nothing but shape changing without removal of material. Shape changing without removal of material. So change in shape is called forming. So in metal forming you want to change the shape. That means you need to apply a load more than yield stress, because when you apply a load on a metal, deformation starts, permanent deformation starts from after yield point only. Before yield point, that is called plastic deformation. If you draw the stress strain diagram, simple stress strain diagram, normal stress. So this is the stress strain curve. A, B, C and D, E. So as we know that A is proportionality limit. B is elastic limit. These two concepts we have discussed in material science, and you may have studied in strength of materials as well. So no need to again go through each and everything. Yield stress, yield point, ultimate stress, breaking stress. So proportionality limit, as we know that till that point stress is directly proportional to strain. As you goes on increasing load, deformation also goes on increasing the same proportion. Slope will be constant till that point. So from there, from proportional limit to elastic limit, so the slope is gradually decreasing. Slope is decreasing, and so strain is increasing, stress is decreasing. So the material behaves elastically till elastic limit. So that's why this region is called elastic region. The region till elastic point is called elastic zone. If you apply load till elastic point and remove the load, and it will again come to the original position. So that's why it is called elastic zone. And if you apply load more than yield elastic point, deformation starts. But we take yield point as the the point where deformation is maximum more deformation takes place. So from the diagram we know that for permanent deformation, if you apply a load more than yield stress, from yield point the permanent deformation starts. So as you goes on applying load, the deformation goes on increasing. At some point it failure takes place. If you apply a load, ultimate stress, where the failure starts taking place, and breaking point is the point where it breaks. So yield stress is the stress at which the deformation starts, and breaking stress, ultimate stress, is the stress at which from where breaking takes place. If the load has to be applied between these two, the load, if you want to do forming operation, forming is permanently changing shape. If you have some spherical ball shape metal, then if you want to convert into square, you need to apply a load, forging generally, right? So similar way here, you need to apply a load more than yield stress and less than ultimate stress. So if you apply more than ultimate stress, it breaks after few seconds. So that's why you need to apply load less than ultimate stress. In forming, the load applied is metal forming forces application applied on metal, stresses induced greater than the yield point stress and less than ultimate stress. Stresses induced are greater than yield stress and less than ultimate stress. So based on this concept here, because in metal forming we have to apply more than yield stress and less than ultimate stress. So that's about the metal forming, the stress, and how much load you need to apply for deformation. Okay. So metal forming is two types. One is cold working and another one is hot working. First one is hot working. So what is hot working? Working or deformation of a material takes place at temperature more than the recrystallization temperature. Deformation of a material takes place more than recrystallization temperature. What is recrystallization temperature? The temperature at which new crystals starts forming. The temperature at which new crystals starts forming or creating. So why new crystals will form? So whenever you want to heat the, suppose if you heat the material, the crystals new crystal starts forming at a temperature, so they gain energy and they form new crystals. So as it goes on increasing, the new crystal become bigger and bigger, and they convert into liquid, means molten metal. So hot working is a temperature. If you want to working on a particular material at a temperature higher than the recrystallization temperature. Suppose if I am doing forming on a metal piece at temperature higher than the recrystallization temperature of particular material. So for each material recrystallization temperature differs. So hot working is mechanical operation taking place above the recrystallization temperature is called hot working. So what happens in hot working? So recrystal temperature is always 1/2 to 1/3 of the melting point of metal generally. And there are some special materials like lead and tin will have recrystallization temperature RCT less than room temperature. So whenever recrystal temperature is less than room temperature, so suppose if as here we discussed that lead and tin have recrystallization temperature less than room temperature. So I am working forging operation on lead material, lead plate, lead metal piece or tin metal piece. I am doing some joining operation by forging operation, so that at room temperature. So the room temperature is higher than the recrystallization temperature, so that's why it is called hot working. So any operation performed on these materials is called hot working operation, because the working temperature is above more than the recrystallization temperature. Similarly, there are a few other materials like zinc and cadmium. For them, recrystallization temperature is equal to room temperature. So for these also hot working, zinc and cadmium. So these are important. So hot working, we have discussed that any mechanical operation performed on a material above recrystallization temperature, above or equal to above the recrystallization temperature. So above the recrystallization temperature, new grains start forming. So if new grain starts forming, what will happen to the mechanical properties like strength, hardness and brittleness, or all these properties. So if you heat a material, generally I am applying load on a material. Suppose one iron rod is there, my objective is to bend the iron rod. So if apply a load without heating, I need to apply more force. Suppose I need to apply for example 100 Newton. I am bending the rod with 100 Newton, it bended. So same rod I heated it to above recrystallization temperature and I bended with 60 Newton. So if you heat a metal, automatically you need less force for the mechanical for forming operation. So that means after heating, strength of the grain size increases, so the strength and hardness decreases. So ductility and toughness increases. So strength and hardness decreases, as I mentioned you told that I am about to bend the steel rod with less force if you heat the steel rod. So that means its strength is decreased. Ductility means easily drawn into wires. Once you heat the material, you can easily draw into wires. Okay. Toughness, it can easily absorb more energy. So all these mechanical properties are related to one another. First one is grain size increases in hot work after hot working. After hot working, grain size increases strength and hardness decreases. Strength is nothing but resistance to deformation. Here resistance decreases. So strength and hardness decreases. Ductility and toughness increases. Similarly, other properties, force required decreases for mechanical operation. Here decreases means we are comparing with without heating, that means cold working. Force required is less, so for in hot working. Similarly, what will happen to the surface finish? So poor surface finish will form. Why? So surface finish, what happens is, once you heat the material, all the molecules on the surface of the component will gain energy and they get more energy. So when the surface finish of the, because they get more energy, and so because of that the surface finish is not good. So poor surface finish will form. And what will happen to the coefficient of friction? So coefficient of friction increases because the molecules on the surface has high energy. Whenever that material moving and other material, so molecule, higher energy molecule will try to stick to the other material, so the coefficient of friction increases. So coefficient of friction increases, and these are the other properties like ductility. Anyway, we have discussed. Next, similarly, cold working. What is cold working? Mechanical operation performed on a material below recrystallization temperature. So what will happen after cold working? In cold working, fine grain size will created. Grain size will be less only because new grains are not forming. Strength and hardness increases. Ductility and toughness decreases. Force required is more. Compared to hard working. Surface finish will be good here and coefficient of friction is less. This is about cold working. So if you want to do any forming operation, so that material must have more plastic deformation zone. So what is a plastic deformation zone here? So if you look at the stress strain diagram, this zone is called plastic deformation zone. Plastic deformation zone. If you want to increase this plastic deformation zone, what you can do? How you want to increase? This is yield stress, this is ultimate stress. Okay, to increase plastic deformation zone, by first method is reducing yield stress. Second method is increasing ultimate stress. So out of these two, reducing yield stress is easy. How to reduce yield stress? Yield stress of a material is reduced by heating. That means if you increase the temperature, then yield stress of that particular material will reduce. Yield stress will reduce. That means it can go plastic deformation at lower force, with lower force. So that's what it tells. Plastic deformation zone is wider. If it is wider, means you can do the plastic deformation of the material takes place at a higher, bigger range of the force. The force range, if the force range increases, the flexibility for operation is more. If the force range is very less, so even you apply a little amount of force, more than, force range is very less, means it will act as a brittle material, and if force range is more, means it can elongate as you goes on increasing the force.